Hello guys and welcome to another game engine tutorial. In this one we're going to talk about some UI tricks with shader programming, which allows you to create something like this. And it's kind of like a cooldown indicator with like a clock scan kind of like effect. Or in here I have another example here in Houdini, which is this, right? You have this degree here from degree 0 to degree 360. You got this skyline effect. You start with white, right? And then when you start running this, it's gonna go scan and it's gonna gradually become white and goes all the way across. Okay, alrighty. So of course we want to do that in the game engine, and this should work in any game engine that supports programmable pipeline for shaders. So here I'm going to right click and create a new material. I'm going to call this guy scan icon. Okay, and then in the scan icon material, I'm going to change the material domain to user interface. Okay, save that. Now there are different ways of doing this, right? I'm going to show you a way that's more like programmer oriented. So we're going to create a custom node and rename this node scanner. Okay, now we're going to write code in this node here to tell the what color will be the output. For the first input, I'm going to use texture coordinate as the input, and so that goes to there. Okay, and then the first input name will be UV, right? UV coordinate. All right, and then here inside of the code, I'm gonna get a reference of the UV. You can hold it down shift and enter to add new lines. Let's add a few more lines so we can start typing in stuff. Okay, I'm gonna do float 2 coordinate will be equals to float 2 UV. That's gonna give us the UV, right? Control and enter. You got an error because it doesn't know what to output. We can return maybe the coordinates to take a look at it, right? So return coordinate. And you also want to make sure that your output type is float 2 in this case, because coordinate is float 2, right? Now you can see we're basically getting this. So there's nothing different now from connect that directly to there, because we're basically reading the value and output it. All right. So now I want to convert this coordinate into a mathematical coordinate that we're familiar with, right? A coordinate, if you can draw that out, a coordinate that has basically x, and this is x axis, and then maybe green is going to be the y axis. Oh. And the center of the image right there, we're going to get 0, 0, right? And here we're going to get 1, 0. Right, and here we'll get 0, 1, and here we'll get negative values. So this is the system I want to convert that into, so I can easily get a circular effect, right? If you can make the coordinate sit in the center, the 0, 0 sit in the center. Unfortunately, the UV coordinate of course starts with a corner, so the 0, 0 is over here or over here, right? So I have to shift that over. In that case, I need to go for float. I don't have to create a new one actually. I can say coordinate equals to coordinate and then minus float 2 0.5 and 0.5. So we're minusing 0.5. Now this wouldn't be enough because this will shift the coordinate over here, but it's gonna make the ending here to be 0.5 and 0.5. We can make it more uniform by timing that by 2, just to make the numbers twice as big, so that the edge will be have a value of 1 for either x and y, or y, right? Run this. You can see now we're getting this, right? And you can see now 0, 0 is obviously over there. That's the darker point. Those are negative values, right? This is positive values, right? That does not feel right. So I need to flip the values for the y. Okay, So I can probably do that with multiplying another float. You know what? Let's make things easier and create a new line for that. Coordinate it equals to float 2 coordinate dot x coordinate dot y, but y will be negative in that case. Okay, you can click anywhere to actually run the code. Right, you can see now how it's flipped upside down. Now we're getting the correct coordinate, right? So here, this is 0, 0. This is 1, 0, right? Red, pure red. Those are all pure red because those are negatives for y. When it becomes a color, it doesn't really show any green in this case. This is a 1, 1, red plus green, right? So this is going to be the coordinate system I'm talking about in common mathematics. Again, this is going to be easier for me to kind of like imagine what's going on. Okay. All right. Now another input we want to get is, of course, the value we want to go for, right? I want a value input that's ranging from 0 to 1. I'll probably name that percentage from 0 to 1. That's how Unreal says about percentage. It's now 0 to 100, but it's 0 to 1. So I'm going to give it a new input called percentage. That's basically how much the scan is going through, right? So I'm going to go ahead and add that. Right, click on that to add a new input. I'm going to call this guy percentage, right? Or percent, I guess. Right, and then I'm holding down S and click to create a scalar parameter and connect that over to the percent. Okay, and this will be called percent as well. And then it's going to be ranging from 0 to 1. Right, from 0 to 1. Here, let me make the value 0.25, meaning that this is 25%. Okay, so 25% means in this case, it means if I can pull up Houdini, it means that we're here, right? We're 90 degrees from the beginning there. This is the beginning, right? We're 90 degrees through. We'll see. We're expecting to have a result that's white in here and black on the rest of the areas, right? And we can visualize that by kind of like converting or creating a vector that is the same as this red line in here, this line in here. Okay, how do we do that? Well, we can use some trigonometry to get that to work. Okay, I need to know, convert that percentage from like a percentage to like a radian, right? So I can say float percentage radian will be equals to percent. That's a percent from 0 to 1. I'm going to multiply that by 360, which gives me degrees, and then I have to be converted into a radian, which is just called radian. And we'll convert that. Okay, I hope I can make this wider, but I can't. All right, right. This is going to be giving me a radian. Probably don't need to make it that long. Percentage red should be fine, right? So of course this is not going to do anything. I need to, if I want to visualize that, I can use that radians to calculate a vector, right? So I'm going to do a float 3. Now you probably are wondering, why are you using 3, right? Because it's easier for me to think of things in 3-dimensional way, because 3D mathematics can do something like cross product, which should be working on 2D, but I just feels like in 3D it's easier for me to think. Right, float 3. I'm gonna call this guy pointer. Okay, pointer is basically a vector that's this vector, the end of the scanline, the edge of the scanline, right? Where is this vector? What is this vector? Of course, this is a 2D vector, but you can see this works in 3D if you just make the z-axis 0, right? That's what I'm thinking. So x will be cosine radian, right? Cosine that. And y will be sine radian, cosine sine, right? And then for z is going to be 0. Okay, now we can return that. And then just in case, yeah, we need to make it float 3. Right, don't get an error here. Oh yeah, this doesn't work this way. Yeah, you have to actually construct one, use the constructor for that, which will work now. Right, you can see we're getting green. It's green because the value, if you imagine what this color means, it just means 0 for red and 1 for green, which is 0, 1. 0, 1 is, of course, right, of course, this coordinate, right, this coordinate here, because we're using 0.25, right? If we increase that by 2.5, right, you can see it's all black. Right, why is it all black? Because you think about it here, this coordinate will be x will be -1 and y will be 0. Of course, it's gonna be black. So 0.6 125. No, 675, right? And that goes a little bit further, but it doesn't really go back because x is still negative values, y is negative value here too. So this wouldn't do anything good, right? But if you go something like 0.4, right, you can see we're getting a darker green because we're seeing 0 still as x, so actually negative value for x, but for y it's gonna be a dimmer, right? It's not gonna be 1, it's gonna be something smaller than 1 for the y. Okay, and that's basically the idea. You can imagine that anything bigger than 0.75, maybe 76, will give you a color. Anything that's smaller than that will be giving you black, right? That's basically the idea here. We're getting a vector now that does represent basically this vector. Okay, this vector here. Okay, the next thing I want to try to do is I want to know the relationship between those pixels, right, to this vector. And every pixel has a coordinate, of course, right? You can think of those things as pixels now, and they all have their coordinate, which is going to be the coordinate in here, basically, if the center is 0, 0. So now after that, I need to calculate the coordinate. I don't have to, it's already in there. I need to calculate one thing called cross product. Okay, so float 3. I can call this cross will be equals to cross product of, actually I need to make coordinate a 3D float, a 3D coordinate, 3D 3D will be equals to float 3. So basically we're converting the coordinate into 3D. So dot x dot y and then 0 for the z. Even it's 3D, but the axis is 0. Right, so we're gonna say coordinate 3D of every pixel. I want you to be doing a cross product to our pointer vector. Okay, and then we can return that cross product and see what we got. Okay, you can see we're getting something like this. Okay, so you can see we're seeing blue color now, right? Which is kind of like the indicator. The blue color will give us a hint of what's going on with its with the value. Let me change that to basically. If I can make it easier, I'm going to save that. So to make it easier to visualize, we can create a new material instance and open that and check on the percent. Okay, I'm going to change that to 0. You can see now, when I drag it up, you can see this thing is just rotating with me when I drag it, right? Right, so for all the pixels, now we start with here, right? And when we drag it up, you can imagine that pointer vector will be this guy. Right, so all the colors that's on the right side of our vector, our pointer vector, will be a positive value for the z-axis. For x and y don't matter; they're going to be 0. Because we're basically cross product will give you a vector that's perpendicular to the two vectors you're doing cross product. If you don't know that, probably you can reference to some of the videos I made before. But cross product, this is the cross product actually. This is the cross product between this line and this line. You can see now whatever you do whatever value that is changing, you're getting a vector that's perpendicular to those two vectors. Now based on the value and angles, you'll get a longer line and positive line, sometimes negative line, right? That's the difference. And it's following a rule we call right-hand rule, right? And the resulting here is that no matter what you do, no matter what you rotate, right, the right side will have a positive value. The left side will not for our vector. That's a good indicator, right? Because we just need to use that as to our advantage to determine, like, do we want it to be white or black? Okay. All right. And we can break that down into two possible scenarios, because using simple math cross product is you're gonna get like a mirrored result, because it doesn't really know if the angle is in a lot of cases, those cross product or dot product doesn't really know if the angle is 130 or 360 minus 130. There's two possible values, so we'll probably have to work a little bit more smarter here. But the main takeaway here in this step is that you know that on the right side of our vector, you'll get a positive value. Okay, that's the only information we need to use on the z. Okay, all right. Okay, now moving on here, I'm gonna do a if statement. Okay, if our pointer dot y is bigger than 0, that means we're on the upper part of the graph, right? Here we're on the scanner is this line. this line is here above the middle. Okay, right? And I know that everything on the right, which is the z bigger than 0, will have to be white, right? So here I can say float return val will be equals to 0 to make everything 0 first. I will return this return value eventually, right? We can say if the pointer y is bigger than 0, I cannot really type in the tab, so I can say if pointer y is bigger than 0, and then the cross product dot z is also bigger than 0, that means it's 0 on our right, right? Those has to be white. Okay, and then we can then say I hope this IDE can be better to type in a tab. Right, if that's also bigger than 0, we can say return value will be equals to 1. Okay, let's run this. Okay, do I got a value there? 0.75. Return val. Okay, let's go save that. We can check it by using our indicator here. So you can see now when we start, right, you can see everything on our right will be white. Okay, of course that's only going to be when we are on the this line. Okay, we're seeing this line now, right? When this line is above. Okay, and also here when I guess we can we can keep on going from there. Another thing I wanted to avoid is avoid happening is that I want these guys to not be white when I'm scanning, right? Those can be all 0. So that's actually another if we can add here. We can say and the coordinate dot y, it has to be also bigger than 0, right? Those two also have to be bigger than 0 to make this work. Okay, let me save that. Okay, now you can see we're making the upper part kind of work on some extent, right? But when I go, of course, to the other parts, it's all going to be black because we haven't even done that part yet. Okay, so here we can say else. Right, else, what do we do? Well, in here, we also need to check if they're on our right, right? Because we only care about if they're on our right. So if cross.z is bigger than 0 also, right? Okay. And I also wanted to say coordinate dot y. In this case, we also make them to be. This actually has to be or. So the logic here is that they're on our right, that's fine, or they're up above, they're on the top part, right? Because we're already reaching to the bottom part, the top part has to be white. So we can say, or this is true, right? If the coordinate y is also bigger than 0, then yeah, of course we want to be white. So oh, yeah, let me add this in here. Have some better indentations. Return val will be equals to 1. Okay, run this. Okay, you can see now we're getting something that looks right. So I'm going to save this. And back here, if I go through this, you can see now we're getting what we want. We start with white, right? And then whenever we start to run this code and changing the value from something that's not 0 and all the way up, it's going to scan over this and then ends up with also all white. That's the behavior we want to have. Now, here, of course, we used basically everything is bigger than 0, so it's actually pretty easy to remember. Right? Everything is just check them bigger than 0. Actually, all the difference between this if and this if is that this one is or, well, this one is and. But the logic here is that we're separating the behavior from top to bottom. For the top, we just check if they're on our white, and then the y has to be bigger than 0 to make the top part work. But for the bottom part, it actually fixes the issue the top part has, right? If the top part is already, if we're already reaching to the bottom part, right, and the top part is bigger than 0, we have an or to make it equals to 1 already, right? That will make it all work. Okay. Now with the scanner, we can then use it to whatever things we want to do. Like here, if I want to add whatever thing, texture, sample, right? We can load in any texture, maybe this guy, and we can then do a lerp, I guess. We can do a multiply. Can create you can see now we're able to scan through this. Of course, we can make the value not quite to 0. Can probably have another variable called shade darkness. Shade value, right? Let me connect that over here. That's going to be also something from 0 to 1, and shade value is 0 for now. We can make it 0.5. Okay, and then we can use that to make that equals to shade value. That way we are able to control this how much we want, right? Too small, so maybe something like 0.25. Too small of an effect. No, that looks better. Right. Now we're able to shade value. Okay. Right now you can see we can go scan it, just exactly like we're seeing in there. Of course, we can make it also equals to like a color if we wanted to. Right. Yeah, probably it shouldn't be like this. It should be more like a color thing, right? So we'll have to output 3D. Yeah, we can have another color maybe. So it's easier to maybe add another interface. Yeah, that would be, that'll be giving us more control actually. So I'm gonna create another one, and this is gonna be the shade color. Okay, and then I'm gonna hold it down V and click, connect that over here. CD, shade, CD, right, for the color. And I'm gonna make it a blue one as the default settings. I basically multiply that with shade CD to get what we want. We can probably also multiply it in there instead of using our code. Right. Times shade CD. And of course we're now returning flow 3. Yeah, now we do return flow 3. That would be fine. Oh, you know what? That wouldn't work because we want those to be all white. It's only that value, and we'll be multiplying, right? So here we'll have to change that. Okay, so we'll have to use 1 minus that, I guess. So I have to change that to bigger or equals to 0, and then this has to be 1 minus. We can clean this up a little bit, but you know, this should work. No, you know what? That's not it. Okay, what am I doing? I'll probably do something. You know how to figure this out. I'm not gonna do this anymore. This should be a very easy approach. So yeah, let's not go too overboard on those shading effect kind of thing. And let's just make things simpler and just return that value. Yeah, not a big deal because I don't want to overcomplicate this. So I'm gonna delete that. Change that to 0. Okay. Yeah, there's one more thing actually that's really needs some tweaking because this is going from here. So you want to flip the values. In this case, we just need to make x equals to y and y equals to x. In this case, we're doing this guy, or we're doing this guy, right? Or here, right? So we can change that from xy to yx. That way we're basically flipping it, rotating it, basically. Right, so let's take a look. Now we're able to go scan from the top. Alrighty, that should be the important things. Everything else I think it's up to you to determine. I think it will be easier to use some node-based way to get the color fit in. Don't want to do all the messes in there. And that's gonna be how we can utilize the shader programming to do that. The language we're using, if you're interested in, is it's HLSL. That's the language used by DirectX. Oh, why do I have that? And then there's another shading language called GLSL, which is based on OpenGL. Those two are very similar. And in Unreal, we're using HLSL. This is really similar to C++ actually. So if you're familiar with that, okay. All right, that's it for this tutorial. Hopefully this is not too confusing. Of course, you can use networking, node networking to get it that this work. But you know, by doing it this way, you're kind of saving some more performance because you're only using the things you need to use instead of using a lot of nodes, and your graph will look actually simpler as well. right? So I think this is valuable, something like you can learn down the way, and when you're building a shader, you can probably utilize this kind of like method to get things done faster and easier. Actually, you can also use Visual Studio to write this. This is actually the Visual Studio version of this. It's HLSL, right? It's the same logic in here, as you can see, and you can it's probably going to be easier to write your code in here and copy it over to there. Right? That's what I do all the time. All right, cool. That's it for this video. Thanks for watching. See you next time.